So what we have here is a panel on the left-hand side showing a vegetated forested surface and a panel on the right-hand side showing an urbanized built-up surface. Incoming solar radiation is the same for both panels, as is the incoming long-wave radiation. So what we see is that the amount of solar radiation, the shortwave radiation that is reflected, is much higher over the forest than it is over the city. And that shouldn't come as a surprise when we look at the albedos of the two systems. We also notice that the latent heat that's being wicked away from the surfaces is different. There's more latent heat involved over the forest, and that makes sense because the trees are transpiring. It's quite a wet environment, whereas the city tends to be hot and dry. The amount of heat stored in the system is quite different. The forest stores much less heat than the urban area. And there's an additional term, the anthropogenic heat, and that's the heat that comes from running air conditioners, having hot motor cars. And you don't get it in a natural environment, but in big cities it plays quite a big role. So we can see that when we concrete over rural and natural environments, we do change the way that radiation is absorbed and reflected and re-emitted. And this creates a positive feedback loop, especially with the increase in outgoing infrared. It's quite a lot higher over the city. That increase in outgoing infrared will then be absorbed by the molecules above the city and re-radiated in various directions.